to some extent, 150 plus million years ago. And we're fortunate to have two people here to offer you that insight, Doug Bradstreet and Mike Scher. And Doug Bradstreet is one of the co-owners of the By Nature Gallery right over here off the southeast corner of the square. And he opened that 5 years ago. And what this reflects actually is his passion and interest in rocks, minerals, and fossils that began when he was growing up back in Connecticut many, many, many years ago. I don't know exactly ask how many, but he worked down in Las Vegas for a while before coming up here to open the By Nature Gallery, and has something on the order of at or near 20 degrees from the Gemological Institute of America, the GIA, which lets him know a lot of things about not just fossils, but rocks and minerals as well. And then Mike Scher is a scientist by degree, a chemist, and that was actually his profession until very recently. But he's very interested in science in general and has become very passionate and very learned as well about many aspects of geology. He's a very fine self-taught geologist. And Mike and his wife Barbara, who's here somewhere tonight, and two boys live in the valley as well. So without further ado, you have two people who are well qualified to give you a glimpse into a really unique, special point in Earth's history from some very unique and exceedingly special rocks that allow us that glimpse. So without further ado, I'm going to turn lights down right away and let Mike and Doug get going here for us.
Thank you, John, for that very kind introduction. And before Doug and I go back into the Jurassic, into tropical wet Germany with you, I want to recap the programs we've been having here. In about 2009, the Geologists of Jackson Hole started offering movies and began what would become a twice a month, that's 11 months a year program, bringing you presentations and lectures from all over the United States. At the time this started, a lot of people said there's no way that you're going to get the audience or the speakers here. And the audience has always been absolutely terrific, and the speakers have always been fascinating and have filled every twice a month, 11 months a year, 2010, 11, 12, 13, 14, and we are actually completely booked. There's one spot open for next year. If anybody wants to stand up here and give a talk next year, a public talk to John now, because that spot will be going quickly. To create this type of a program in a big city would be a challenge. We have a program here that cities that are 100 times our size would be envious of. The science adult education twice a month, the quality of lectures, the audience, the questions they bring, it's absolutely terrific. And I would like to take this moment, and I think I speak for hopefully everyone in this room, and everyone who's been in this room for other lectures, to thank the one person who's been really 100% responsible. It's his energy, his organizational skills, and his vision that have created this Tuesday night program that has so broadened my horizons, and I think everyone's here. Please join me in thanking John Hegerberg.
On to the Jurassic.
And now, without further ado, we can go back into the Jurassic. One of the things we want to communicate here, and Doug and I are both extremely passionate about rocks and fossils, and from a number of points of view. They have incredible scientific value. They teach us about the ancient world, the truly ancient world of hundreds of millions of years ago. In addition, they actually shed light on things that are going on today and how the species that are here today got to be here, how climate change factored into past life as well. And at the same time, these fossils also have an intrinsic beauty and value that we want to also communicate. So, these are some of the world's greatest fossils. And what I'm going to talk about is where, when, and how the Holzmaden and Solnhofen were formed. What was the world like? What makes these fossils so special? And Doug is going to get to show you the real stars, the fossils. So the fossils from the two quarries are very different, and they're up here on the table. It's our goal to finish the presentation with enough time for a Q&A, and then also time for people to come up and actually inspect the fossils. If you have to leave early, if we run on and talk too much and they throw us out of the library, then you'll have to go over to the By Nature Gallery to see. But that's our goal, is for you to be able to come up and see these and look at them yourself carefully. On this table are the Holzmaden, and you can tell them apart very easily. The background is black, dark gray. The Solnhofen are a cream color. So they are very different in appearance, similar, but there are some similarities in the deposition. If you notice the fossils on this table, there's a really big megafauna. This table, there's a whole lot of other things. And again, this is because of how and when they were deposited. The Solnhofen has over 550 species, so it's a real view of a whole ecosystem. So this is Europe today. The H is Holzmaden, the S is Solnhofen, and they're in southern Germany near Munich. I'm going to try and set the timeline here. So this is the Earth's history, 4.6 billion years ago to today. First life, about 3.6, 3.5 billion years ago. This next arrow is at 2.8 billion years ago. Something very critical to our life here in the valley. Anybody know what that 2.8 billion year old event was? I know some of you do. The Teton granite and ice were formed. And then you skip up to a little 540 million years ago, and life becomes multicellular. And this is when we start to get trilobites, worms, and other more complex things. This piece of the timeline is this little piece up there. So as far as the scale of life on Earth, we're getting near our end, anywhere in here. This next arrow, this is the Permian-Triassic extinction event, the mother of all extinction events. 95% of all species die. You're going to meet some survivors in this talk tonight. Animals that survived this extinction and even the subsequent extinctions to be with us today. So this next is just that scale that was off to the right. First dinosaurs in the Triassic. The last dinosaurs in the Cretaceous. That's the age of the reptiles, the Mesozoic. The fossils we're going to see, the Solnhofen, the end of the Jurassic, very close to it. Those are the cream-colored ones over there. The Holzmaden, almost the beginning, not quite the beginning of the Jurassic, but 30 million years after, and that's this table here. So, what was the Jurassic like? And it's about a 56 million year period. It's the middle of that age of reptiles. Mammals are here, but they're mouse-sized, they're tiny. This is the age of reptiles. Reptiles rule the sea, and you're going to see some of them. Reptiles rule the air, you're going to see some of those as well. And the land is where the dinosaurs are. The climate is much warmer than today, over 5.5 degrees warmer. Carbon dioxide, much higher, 5 times today's levels. Also, oxygen is much higher, which is not something you think about changing, but oxygen in the Jurassic was 1/3 higher than it is today. Now we're going to sort of look at the configuration of the plates and the tectonic geology. So I'm bringing us back before the age of the reptiles. This is just before the big extinction event, the Permian-Triassic extinction event. And the continents are arranged in a supercontinent called Pangaea. In about 4 million years, life is going to suffer its greatest blow ever. We bump up into the Triassic. This is the age of where the dinosaurs begin. This little star over here is the future location where these and these fossils were quarried. And remember, these two quarries, they're only about 100 miles apart geographically, but they're 30 million years apart in the time scale. So as we enter the Triassic, this supercontinent is breaking apart, and you can see it here. This is the rifting that's separating North America from Gondwana, which is the other continents outside of Eurasia. The Holzmaden is going to be deposited in about 10 million years. This ocean right here is going to become the Mediterranean Sea eventually, far in the future. And this is the Solnhofen. This is the time when these fossils were deposited. The North Atlantic is completely opened. North America is totally separated. This is still a big supercontinent, but it's going to start breaking apart soon. But that's not part of this talk. Let's talk about fossil preservation. These fossils give us a small glimpse, a window into what life was like 180, 150 million years ago. And when you see all these here, or when you go to my nature gallery and you see even more, you think, God, there's an awful lot of fossils. But fossils are actually a very, very rare event. And the way I try and, almost the one thing that I'd like you to remember from tonight's talk is just how rare and unusual this is. An animal or plant has to die. It has to be buried. It can't be eaten, scavenged, broken apart, and the atoms and molecules in it have to be either carbonized or replaced with minerals. And then that has to stay in one place. It can't get subducted under an ocean plate. It can't be eroded away. It has to wait until somebody either finds it on the surface or digs it out of the ground. And it's kind of a rule of thumb that other than right after the extinction events, the number of organisms on the planet has been fairly constant. So if you think how many organisms are on Earth right now, alive today, not just people, but animals, reptiles, ants, all these things, it's trillions. And when you multiply these trillions times hundreds of millions of years of generations of plants and animals, you can get a sense of how many organisms there were. How many fossils are there? A tiny, tiny fraction of that. So there are very few times and places that preserve these things. Bones and shells, they're hard. They're often made of calcium carbonate. They preserve fairly easily. What makes the Holzmaden and Solnhofen so amazing, and what you're going to see, what Doug is going to show you, is you're going to see antennae of shrimp. You're going to see the skin of these animals. Scientists can actually even see blood vessels that have been preserved for 150 million years. And feathers as well. And some of these fossils have truly changed the world. This fossilization of soft stuff, skin, feathers, this is a 1 in a trillion occurrence, 1 in a billion occurrence. No one even knows. But it's not something that happens very often. I find tons of fossils here at the Tetons. I've yet to find anything other than hard material. Well, and some leaves. Here are the actual quarries. So here on the left, this is the Solnhofen, and you can see the color of the rock, it's the same. The Holzmaden over here is the dark gray. These quarries have been dug for centuries, and the key to finding these fossils is that there were hundreds of people digging these quarries 5 days a week. It was industrial scale quarrying. They weren't looking for fossils. They were using this stone to make floors, countertops, tables. They were using this to make walls, roofing tiles. And it's that large scale quarrying that turned up fossils. So a worker there might dig all day, he'd find one fossil. But the fossils were never the point of it. It was, for them, quarrying the stone. Regrettably now, the Holzmaden fossils are closed. Germany can import hard shale like this from Brazil for less money than they can dig it themselves. So these fossils are becoming rarer and rarer. Let's talk about the setting. As you saw from the map, Europe was covered by a tropical sea. The Holzmaden shale, and can I have some help with this word? Poseidon-Schiefer, how's that? Did I get it here, Hart? Poseidon-Schiefer. Very good. Schiefer. Okay, thank you. So Germany, at this time in the Jurassic, was at the same latitude as Houston, New Orleans, Jacksonville, Florida. Today, it's actually at the same latitude as kind of central Montana. And remember, the Earth is 5.5 degrees warmer. So this was truly almost equatorial, tropical. The Holzmaden deposits were far offshore, and that's important for the type of animals we find. The shale is anywhere from 16 to almost 50 feet thick, depending on where you are. And it was deposited over 500,000 years. It's also not completely consistent. It's not like it's just this 50 feet of black shale. There's layers of limestone in there. In 500,000 years, a lot of stuff can happen. There are floods, other events, there's changes. This shale is a very fine mix of clay, minerals. The minerals are iron and sulfur, and that's important. The organic content is really high, up to 15%. And during World War II, Germany actually mined shale from this quarry to produce fuel because they couldn't get fuel from their traditional supplies. The iron and sulfur together form iron sulfide, and they actually will precipitate out and put a beautiful golden color on the fossils, and we will see some of that. So, and that's also called fool's gold. This only happens in very low oxygen conditions. The preservation of these fossils. The surface has lots of things swimming around, flying above it. The bottom, and this is the key to making good fossils, is very low oxygen. Almost a poisonous environment where nothing can live and disturb something once it settles down to the ground. If there's crabs and snails down there, whatever falls down, they eat it. In this case, no. It fell down and it stayed there and nothing disturbed it. In addition, very low energy, low currents. Even with that, ichthyosaurs like this, 8% of them are articulated like this. 92% of them, the bones are scattered. It's even with this low energy, 180 million years takes its toll. This shale also continuously precipitated down, about a millimeter a year, burying it. What they do find is the best preservation is the side that fell down onto the mud, because that got preserved more easily, and the mud surrounded it. This mud penetrated all the pores and actually shows us the skin, the soft tissue. And you'll see pictures of tentacles of a squid that are 180 million years old, preserved with mud. When you come up, I don't recommend you touch this, but it's very hard. It's a shale, but it's a shale that's been compressed with thousands of feet of sediment. Not metamorphosed, but compressed. This is a kind of a little geologic map. This is the basin. This is where the Holzmaden was deposited. Up here, Oslo, Norway, Stockholm, just to give you a sense of where in Europe we are. Lots of ocean. Aberdeen, Scotland, Prague. The sediments came from here and were washed 60 to 100 miles. And again, they're very fine sediments. That's why they didn't settle out immediately. They were able to be carried by the currents to be deposited in this basin. So the first major fossil find was this guy, Bernard Hoff, whose name we're going to see again. He came here to get oil. Instead, he found an ichthyosaur and changed his life. And his descendants' life, because they still run. The museum founded with his fossils is run by the third or fourth generation. And this fossil that he found totally changed scientific thinking about how an ichthyosaur was built. And Doug is going to talk about that because his ichthyosaur shows exactly some of the features that Bernard Hoff discovered back in 1892. And with that, I'm going to turn it over to Doug to...
Thank you, Mike. Good evening, everybody. Can we maybe turn the lights up just a smidgen so we can actually see the fossils? I'm going to talk about plesiosaur first. It's, looks like the Loch Ness Monster. So a lot of people think that Nessie really is a plesiosaur that has survived. There are over 100 species of plesiosaurs. Very few have ever been found, and they reach lengths of up to 33 feet. I wish I had one, but literally only 13 were ever found. Here's a full skeleton. We actually have in the gallery a few years ago an Elasmosaurus, which is a species of plesiosaur. And I can tell you they're one of the most vicious things you'll ever see in your life. The way the teeth are angled, the way that you can just tell if that thing bit onto you, there's no getting out. So very, very vicious. Here's one of the fossils. Kind of a neat thing in the slide here is right there. You see that? It's actually an ammonite. So a lot of the fossils that you'll see from Holzmaden actually will have shells, brachiopods, and ammonites in the actual shell itself. Ichthyosaurus, one of my favorite. We actually just sold, this is a very small specimen. We just sold one that was about 6.5, 7 foot long just a few weeks ago. The one that I'm showing you here is pretty amazing. Ichthyosaurus is one of the most important fossils on record. There's a lot of features that this animal had that really kind of proves evolution really truly happened. Longest known species can go up to 60 feet in length. What's important is they breathed air. So most people look at this when they walk in the gallery and they think they're looking at a dolphin. Dolphins are mammals. These guys actually gave birth to live young. Most reptiles, there's 5 known reptiles today that actually give birth to live young. The rest still lay eggs. So in a time of the dinosaurs, when all the dinosaurs were laying eggs, this little guy comes around and starts giving birth to live young. There's actually a specimen in the Houston Museum that has 7 embryos still in its belly. One of them is actually in the birth canal. This shows, it's hard to tell because it's so blown up, but there's an embryo here, 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 and then there's 2 more that are not visible. Extremely rare. And this is my guy. A couple of really cool things about this is if you look at all the black, that is the actual skin impression of that animal. It is, the rarity of these guys, you're talking a percentage of a percent will ever have skin left on it. So this particular guy is all original. It's in the original matrix rock, the original shale. And when you get up here afterwards, you take a look at it, you'll see a lot of shell fragments that makes up this entire matrix rock that you're seeing. And Mike was gentle, but it is super hard. You know, this little piece here is probably close to 100 pounds. So very heavy material. So since 1939, 30 quarries were operating, 100 ichthyosaurs were ever found. 8 of them are complete like this. Since then, there's quite a few more, but most of the ichthyosaurs that you'll see, especially in museums, they actually take bits and pieces of ichthyosaurs and they build one. So when I find one that's fully articulated in the original matrix, it's probably the only one you're ever going to see up close and personal. This is a really large guy that it's just too bad. This piece is probably 1,500 pounds. Let me go back to that one more second here. If you look at the paddles, what do you think those were at one point? Hands, feet. This guy actually evolved from walking on land to being in the ocean. So, you know, it's a creature that truly overcame great bounds. And why do we think he went into the ocean? Food. A lot more food. Right here, you see that little guy? That is a belemnite, which was basically the rostrum of a squid. So, which is the next, go the wrong way, sorry. So this is a squid, all the tentacles. This is the belemnite right here. And that is basically this part of the animal. I've been doing this 30 plus years. I am old, you see. Never seen tentacles of a squid preserved. Never. I've never seen one live in person. So this is one of those specimens that truly is remarkable. This part here, we're not 100% sure what that is. That may have been the stomach contents of that actual squid. Ammonites. Everybody has seen ammonites before? Yes, most people. What's interesting, and this is a small specimen, but this is the most prolific fossil you'll find in Holzmaden. There are so many of these that they see them and they almost kick them to the side because they're so common. There's that many of these guys. And I have a bronze sculpture here that kind of shows you what the ammonite actually looked like. Most of the time when you're seeing a shell, and we've got one on the other table, most of the time what you see is right up to here. Can everybody see that? This part is the living chamber of the animal. So this squid-like creature actually lived in the end, and the actual curve of this animal, if you cut it in half, is chambered. Those chambers would fill with a gas or water, and that would cause it to be very buoyant in the water. Modern-day submarines were invented from research on these animals. Crocodile. These guys reached incredible lengths. I've seen one. The next picture here is the one that was in Tucson just a few years back. This guy, they had one that was close to 10 feet in there. Crinoids. Animal or plant? Animal. It is an animal. Very similar to a sea anemone of today. Crinoids are really special, and the ones out of Holzmaden are the rarest in the world. They're the most unique, and tend to be the most expensive. This is one whole colony of a crinoid. It's unbelievable. You are talking the length on that graph to the next. There's a log, driftwood, right here. You see that? This plate was 60 foot by 20 foot and has over 230 crinoids. The head, or the crown of the crinoid is here. This is actually a really special piece because it's actually an entire colony. Trying to shut it down on me, John?
No, trying to do it right.
So you have one crown here, here, 1, 2, 3. So that is actually a really petite colony, similar to what you're seeing up here. This is kind of the idea here. You have a piece of driftwood that these colonies latch onto, and they curl themselves around. In about 2 years or so, that driftwood gets saturated and actually sinks to the bottom. You see you've got ammonites on the bottom, and they kind of get wrapped up in themselves. There's bivalves attached generally to these logs. The one that we have here has some shells and shellfish type of things attached to it. When we find them, it's hard to see, but there, if you see here and here, here, those are all the stem of that crinoid. Huh? Sorry, John. You're not going to win on
Try
this
to
one.
take care of you.
So basically, when we find these guys, when we see that they're there, the better side is the side that's going to be facing down. So they pour resin all over it, cover it with some plyboard. They cut it out, and then the process of pulling that fossil out begins. This material is so hard, a little piece like this could take 2 to 4 years just to prepare it. Imagine that big plate, that 60-foot long one, I think it was 18 years?
18 years.
18 years to prepare it. The Solnhofen, on the other hand, is a limestone. It's very soft, and modern day dolomite powders and such, it's very, very easy to prepare. This stuff is extremely difficult. So this piece is about 5 foot tall, partially prepared, not fully done. This is another piece. This was just offered to me last year, and I can't fit it in my store. It's too big. But again, the key thing here is the driftwood, which is right here. And then if you look at the size of these crowns, this is a piece that is really, truly one of a lifetime. The 60-foot and this one are the only two really big pieces I've ever really seen. This is Martin. He's 6 foot tall. If that gives you any idea of how big this plate is. This crown is about 30 inches across. Largest ever found is about 39 inches. And again, this was a piece that was offered. It's massive. This is a $500,000 fossil.
Doug, where are these pictures taken from? At the quarry?
Yes, in Holzmaden.
Okay.
Martin is owner of one of the quarries. This is my piece that's in the gallery right now. Impressive all on its own. Again, driftwood. You've got all the shells and bivalves. The thing that's interesting about this crinoid, and you can't see it here, but if you come into the gallery, each stem of that crinoid, the cross section is a perfect star. That's a $100,000 fossil, just so you know. Very rare. to be able to get pieces like this anymore, they're really all coming out of private collections, things that people have held over the years. Even like what we see at Green River here in Wyoming, when we quarry, they stockpile all the stone. They pull it out, and they pull it out, and then over years and years, they'll pull out a slab and they'll start to prepare it. Pterosaurs, flying dinosaurs. First vertebrates to transition from gliding to flying. By the Jurassic, they have become established globally and adapted to different habitats. I have brought a pterosaur from, isn't that supposed to be the Solnhofen?
Well, they're both. There's another picture after this of,
That's right, that guy. Dorynactus. This guy, look at the teeth. We're going to show you slides a little bit later when we get to Solnhofen of Orangopteryx, which has teeth like this as well. They're pointed out. They're a really interesting creature. These guys basically hunted fish. So
this is my slide.
Solnhofen. We'll let Mike talk about Solnhofen for a little bit, and then we'll get to those fossils.
So we're going to switch. We're going to jump 30 million years, but only about 100 miles. And we're going to leave this dark, Kerrigan, organic-rich mud for this nice, clean, white stone, Solnhofen. And there's a reason why these look so different. The Solnhofen is a near-shore deposit. 30 million years, climate is still warm, it's still ocean, there's still big land masses to the north and west, but all these coral reefs have grown, and mounds of sponges and stromatolites, which are algal mounds, and they've created these very quiet lagoons. And the lagoons, because this is a really hot tropical climate, become very salty, and the water stratifies, the salt water sinks, and it creates that anoxic, poisonous condition at the bottom. This formation is about 300 feet thick. They're still quarrying it. It also is a snapshot of 500,000 years. Again, this is only less than 1% of the Jurassic. The lagoons are relatively shallow, 100 to 250 feet deep. The other thing that this real salty water encouraged is there were bacteria that could actually form mats that would create almost a shroud over the fossil, further protecting it. And that's what allows all this soft things like antennae and the other things you're going to see to be preserved. Very low current, so none of the remains get scattered. The best way to think about this is it's probably analogous to areas in the Persian Gulf, very hot. Maybe the Bahamas also. We also know there's fresh water nearby because we find freshwater animals, insects like dragonflies that can't live without fresh water. This limey mud, again, penetrates the animal and preserves incredible features, wing membranes, blood vessels. This stone is easy to split. There's clay layers in it, about 20% clay, which are washing in from the mainland. And that allows it to split, and when you split, that's when you can get the fossils. This is kind of a diagram. This would be these salty bottoms, and this would be the lagoon, surrounded by little coral heads and little sponge reefs. The top of the water here isn't poisonous, and so fish, crinoids, they can exist there. And the crinoids that are living here are very different. They're not stalked, because if they lived at the bottom, they'd die. So they're free floating. And in fact, the crinoids that Doug talked about here lived in that formation, and they had to adapt. Most crinoids grow from the bottom up. These grew from the top down because the bottom was poisonous. They couldn't live on the bottom. It was anoxic. This is a modern day quarry. And this is what happens with a lot of that stone. You get a patio made. But if you look through enough of this stuff, like tons and tons, you can find some pretty amazing fossils.
Pardon me for a minute, has anybody been to the Green River Formation quarries here in Wyoming? If you go back one slide, Mike. Does that not look like the Green River Formation? I mean, every quarry down there looks identical to that. I mean, it's amazing how similar they really are.
Limey mudstones.
Yeah, it's incredible. Floating crinoids. Let me get to this side now. Floating crinoids can basically be found in every piece of limestone in Solnhofen. This is what's thought to be the bottom view per se of this animal. And the feeder mouth would be right in the center there. Brittle starfish, which I have a couple for you to look at today as well. 5 segments, and what's amazing with nature, of course, is everything is symmetrical, asymmetrical. I mean, 5, this is a modern day starfish, and you see how the mouth matches up to each of the arms. Dragonflies. Look like modern day dragonfly? They haven't changed hardly at all. So this is actually a positive and a negative, which we had and we've sold it, so I brought another pair for you. But what's really interesting about these things is when we split them, when you have the positive half, that's the actual animal, then you have the negative half, which is going to be the trace fossil. To get both is quite amazing. It doesn't happen very often, and imagine how thin a wing of a dragonfly is. It's amazing to even think that it would have the ability to turn into a fossil. I've got 3 of them here for you to look at. Size and body plan are very similar to today's. You almost can't tell the difference. Horseshoe crab. These, we had one of these as well, which we would have brought but we sold. But what's really cool is one of the most successful forms. They're still around today, obviously. Go back almost 500 million years. And the tracks here basically show the final moments of this particular crab. They were able to withstand, low oxygen, very hostile environments, very hardy creature. There was one in the Houston Museum that was on display from Thermopolis that the length of this wall was the entire track of that horseshoe crab. Shrimp, again, hasn't changed much. It's almost identical to today's. When we're done here, I'd like you to come up because all of these antennae are beautifully preserved. The eye, all the hairs on the legs. And on this one, I have 2 of them actually, you can actually still see the shell of the shrimp. The dendrites that you're seeing here. Almost every piece of Solnhofen that you'll ever see is going to have these dendrites. It's one of the easiest ways to tell whether it's from Green River Formation or whether it's from Solnhofen. Solnhofen almost always has these beautiful dendrites. That is a Gyrodus, which is a moonfish. This guy had rows of teeth that were all round, and it basically was a coral cruncher. We have a smaller one on display. The larger one's got to be about this big and about that tall. We sold 2 of them, and there's only a handful of them known to exist. Mike, I'm going to let you talk about this guy.
Thank you.
This is Mike's baby.
Yeah.
So, can you say more about the dendrites a minute?
Yeah, it's actually a little bit further out. We're going to talk about it. Yeah.
Actually, I think that they were. Okay, no, you're right.
They're a little bit further
They're
out.
coming. So, does anyone recognize this fish? Somebody say it. Kitty?
I think it came from Madagascar, didn't
South Africa. Oop, sorry.
it?
This is Solnhofen. This is a 150 million year old fish. Very rare then. Their appearance from 250 million years ago to today is unchanged. But you know what this is, say it. Coelacanth. Here it is. Look at this. Look at the tail. So coelacanths have this amazing story, and someone could do an entire talk about them, but we're not. They appeared over 400 million years ago in the fossil record, 410, 420 million years ago. They kept appearing in the fossil record until about 100 million years ago. The one on the top, 150, they find a few more. 100 million years ago, they stopped finding them. They don't find any. Scientists are convinced these animals went extinct 100 million years ago. In 1938, actually in a fish market, somebody discovered them. These are the true living fossils. And these are true survivors. These fish survived the Permian-Triassic extinction event. It killed 95% of life on Earth. They survived Triassic extinction events. They survived the KT event that killed the dinosaurs. One of the features, one of the things that this fish does is it lives in very deep water. It also has the ability to enter a low metabolic state, almost like a hibernation for an animal. And so, because of these qualities, it was somehow able to survive when almost everything else didn't. In addition, if this story weren't compelling enough, about 380 million years ago, the coelacanths split into another group. And that other group came onto land. And they became the first vertebrates to live on land, the tetrapods. And all the other land vertebrates in the world come from that.
You're a great coelacanth. So this is the plate that is up here. And I have a single here of this guy. What does it look like to you? It's like a crab. What else? Lobster. What else? Maybe a shrimp? It's a combination of all of them, actually. And quite a crate. That's an all-in-one buffet right there. It's beautiful. We don't see them very often, so you definitely want to come up and take a peek at that afterwards. This one plate here with the gyrotis is a piece of mice, but all the others you can certainly come into the gallery and get really good close-up looks at all these guys. The Cycleron, which is the all-in-one buffet there, you don't see very often, you don't see them very good. So you've got two really great examples here.
Dendrites, Doug.
It's coming.
Oh, okay.
It's coming.
This is a slide I don't know about.
I thought you had it in there. Because you talked about the manganese. I think it's in there.
Okay.
I'll talk about it. If it comes up again, then we'll just ignore it. Dendrites, as I said, are very, very important in Solnhofen. And most people look at those. Let's get a sign of who thinks it's a fossil fern? Who thinks it's a mineral? Mineral has it. Basically, when it's black, the mineral manganese is what causes that. And when it's red or orange, it is iron. And it's a mineral deposit, and it's very prolific in this limestone. It's almost impossible to find a piece of limestone from Solnhofen that does not have them. It's that important in that area. But there is a slide coming, Mike, you'll see. Beautiful ray. Again, this area, you've got preservation on here that's cartilage. You don't see that preservation in any other fossils in any other parts of the world. Normally, to find a piece of this is rare. I think this was what, $150,000? $180,000 for this ray. It's extremely rare. It's a big one. It's almost 65 inches long. Turtles. This guy at about 12 inches long, how much do you think that's worth? Any guesses? It's about $200,000 for a really nice specimen. A beakfish. There were about 100 different fish species in this area. These beak fish got up to basically 10, 15 foot long. Other fish in that area got up to 20 foot in length. Pterosaurs. This guy is a Rhamphorhynchus. And you see those menacing teeth? I've got a pterodactyl here that you're going to see, and you're going to see the teeth are completely different on these guys. It's just a different species of pterosaur. They became extinct in the KT extinction event. About 100 skeletons have been found. Beautiful Rhamphorhynchus. These guys, 12-inch to 6 foot in length. Most people thought that pterosaurs were always huge. It's actually quite the opposite. Most of them were a lot smaller, basically like seagull size. Texas, however, had them lengths of 10 feet, I guess.
33.
33.
As big as a plane.
Little Piper plane or something.
Everything's bigger in Texas, though.
And again, take a look right here. There's always little things in these places. That's actually a floating crinoid. And I think on our shrimp plate here, I can show you some live in person when we're done. This is what we think the guy looked like. Not quite sure about the tail orientation, but you see the claws that are most famous on these guys, and again, the teeth. This is one of the most amazing Rhamphorhynchus. This has all the membrane still in the wing. This guy, found in 2001, it's been used with ultraviolet light. You can actually see blood vessels within the membrane of this guy. Again, look at the teeth. And when you see the one I brought for you, teeth are straight up and down. The Rhamphorhynchus always had these angled teeth. Mike, you want to talk about this one? This is another one of your favorites. This is a try-kill piece. There's 3 deaths going on all at the same time.
This is a triple mortality play. So the Rhamphorhynchus, and this is a better view of it, has a fish that it just caught. And this is the fish head. It's actually right in there. Using a microscope and UV light, you can actually see the spinal cord of the fish. The fish was not, it was ingested but not swallowed. It wasn't vomited back up. It's still right here in the pouch. Right after it caught that, the big fish, and that's its bill right there, came and speared the wing of the Rhamphorhynchus. And because beak fish, they have very sharp teeth, but they can't open their jaws very far. So it couldn't open its jaw to rip the wing up. It tried to shake it and knock it loose, and they can actually tell that from the dislocation of the bones in the Rhamphorhynchus, but it couldn't do it. And so eventually they both settled down to the bottom, and they both drowned because there's no oxygen at the bottom, and the Rhamphorhynchus has to breathe air anyway. So this is a triple murder, triple predation. But the point of these fossils is that the detail is so incredible that you can actually see how an animal died. In this case, you can see how 3 of them died.
Thanks, Mike. I'm not the only one hitting the wrong button.
There you go.
This is a classic Solnhofen pterosaur, Pterodactylus kochai, and I can promise you'll never be able to get this up close and personal to one. This is a specimen. I'll let you touch it. Just let me hold it when you touch it. It's a $150,000 fossil. The preservation on this guy is just absolutely amazing. You've got all the claws on the elbows. You've got the whole wing, the legs, the tail. You see the dendrites even running all the way around and actually into the bone itself. And look at right there, it has all of his teeth. This species was first described in 1837. There's about 20 different species in Solnhofen alone. So a close-up of the teeth. The fourth claw was elongated and used to support the skin that attached to the wing, and the fifth eventually just kind of dropped away. Pterosaurs became extinct at the KT event, just like their land and sea-based friends. Archaeopteryx. Mike, do you want to kind of duel up on Archaeopteryx? This is one of the most important fossils ever found. I have a small one for you here that's a replica. The real fossil, you can see in Thermopolis, it's $1 million, that fossil. They're extremely rare. 12 have been found over the, 12 have been found ever. The first, no. There's the museum. Yeah. The gentleman that owns that has one of the largest collections of Solnhofen anywhere in the world. The display that at the Houston Museum took their entire lower level, and it was all his personal collection. Huge. Yeah. Archaeopteryx is the size of a raven. It has both theropod and bird characteristics. The bird characteristics include flight feathers that are similar to today's bird feathers, wings, and a wishbone. The reptile characteristics are the teeth, the claws, the long bony tail, and some skeletal features. Again, the closest one that you can see is in Thermopolis. It is an amazing thing to see. You want to talk about it for a little bit?
Sure. So, just before they found the first Archaeopteryx, they found a feather in the Solnhofen. And all the Archaeopteryx, all 12 of them, have come from the Solnhofen. They're discovering relatives of them in China in similar age strata. But this feather they found before the Archaeopteryx, and it was found 160 years ago. We're still studying it today. As our technology gets better, we actually can pull more information out of this. So they were able to, by using electron scanning microscopes, find the actual melansomes that contain the pigment that colored this feather. And they can determine that this was a black and white feather. So the science here is truly remarkable and what it can teach us about these. The importance of this fossil can't be overestimated. 1859, Darwin publishes Origin of the Species. If you think that theory is controversial today, imagine what it was like 160 years ago. You know, they were probably ready to burn at the stake.
And they actually keep reclassifying Archaeopteryx. They say it's a dinosaur, and they say it's a bird. They're literally, truly, to this day, every year they seem to reclassify it. It's a fight every day on how to deal with this fossil.
Right. But one of the sort of soft spots in Darwin's theory, if you will, is that people said, well, if all these animals change from one thing to another, where are the transitions? Show us in the fossil record where X becomes Y. Well, 2 years after the theory is published, they find Archaeopteryx. And here it is. Here's the proof that he needed. It's an animal with feathers, so it looks like a bird, but it's an animal with claws and teeth and bone structure like a reptile. It's the transitional fossil. This is the Thermopolis Archaeopteryx, and you can see feathers. These are tail feathers down here. You see the head, the claws. So this is arguably, if you take out hominoid fossils like Lucy, this might be the most important fossil the Archaeopteryx ever discovered. Anything you want to add about this?
No, you did great.
This is what this bird/reptile might have looked like. The claws here were great for climbing up trees. The wings would allow it to glide. The color scheme is probably wrong. This drawing was done before they did the study in 2011 on what the actual feathers look like. We hope you've enjoyed our trip into the Jurassic. This is the crinoid, the ichthyosaur, Archaeopteryx, and now we're ready for questions.
We really encourage you to come up and look at the fossils also.
So, questions?
Why do you think there's such a high concentration of fossils in that area of Germany?
It's actually the same everywhere in the world.
Is it?
Green River Formation in Wyoming is the largest dry lake bed in the world. All conditions were right. So in that area, you find a mass mortality of all these fossils. The same can be said about Solnhofen. All conditions were right. Holzmaden, all conditions were right. And you can go all the way around the world. The Volga River in Russia, high concentration of pyritized ammonites are there. It's all conditions are right in certain areas. So you could travel, for example, dinosaurs in the United States, Montana, huge area for it. Everything was right. Then you go to other places where conditions just weren't right. You don't find anything.
Or things were eroded. And even though they were concentrated here, you could dig in the Solnhofen all day and be lucky to find one fossil.
The folks that have been to the Green River Formation, did you dig?
Yeah.
Did you find a lot of fish?
Yeah.
Yeah? It's because you know exactly where they're at. You know, even when you know where they're at, if you're splitting, if the folks at the quarry didn't tell you the layers and you just start splitting, you can be there a month and not find a thing. We have a partnership with several of the quarries, and there's one section that they'll work a season. And even though they know there's fish there, they can go days or weeks without finding anything. So it is extremely rare to find a fossil. And to find them at this level, it's astronomical. Think of every person on the planet. And some of these fossils are so rare, it'd be like one of those individuals would fossilize. It's that difficult to find.
Maybe you've heard it before, and I'm sure there are bird people here who know it better, but it seems to me I heard that birds with black tips on their wings migrate long distances, like pelicans. Something about how black tips are
Well,
stronger.
apparently the black does stiffen
Yeah.
and strengthen the wings. That's what I read doing the research.
Long distance migration. Wow.
Yeah, but we have no record or no way to determine whether these did or didn't. Remember, it was a tropical region, and these fossils are so rare that Archaeopteryx type fossils are found in 2 places on the whole planet.
What university in the United States is doing the most research on fossils?
It's almost impossible to say.
University of Utah, anyone with a good geology department.
Yeah, the Museum of the Rockies is phenomenal.
Where's that?
It's in Bozeman, Montana. It's one of the few museums where the specimens are all real. Most people think you go to a museum and you're looking at all the real thing. The truth is you'll see more real things in my gallery than you'll see in a museum. Most of them are cast. So, because of the expense and the rarity of them. So, but the Bozeman, Museum of the Rockies, if you haven't been there, it's worth the drive. It's one of the best museums in the country.
And the weight as well. If you didn't cast them, fossilized bone is very heavy. One of these dinosaur vertebrae could weigh 50, 60 pounds if you have to support.
We consider the Smithsonian one of the finest museums in the world, and they still do not own their own T-Rex. They just got one on loan. So, it's a difficult thing, but Museum of the Rockies is amazing. The Houston Museum of Natural Science is amazing.
Jim?
Is there anyone putting all this together? Anyone working in the different countries that is putting together a sort of a chronological picture of what all these animals look like and what country they're from and
Well, actually, Actually, there's a great book over there, which I got on interlibrary loan, which describes crinoid assemblages from the Ordovician until today. And
It's a conglomerate of people that are
And so
doing
it's
this.
it's a mass effort, but this is a book by 4 or 5 authors that describes crinoids that are found everywhere from the U.S., which has incredible crinoids.
Barbara's holding it up.
To Germany, right. The University of Wyoming has it, and our library got it for me so I could use it for this talk.
The thing you have to remember is every year we're finding new things. As the land erodes away, as technology gets better, there's more and more people that are finding things. And there's a battle in the industry, I call it the industry, between the scientists and the commercial folks. I'm a commercial guy. I love it, I have a passion for it, but it's kind of cool to make a buck doing it. But a lot of the scientists are angry that it's commercialized. However, every major important find in paleontology has been made by amateurs. The average guy going out and digging going, wow, what the heck is this? So, there's a huge, I deal with the quarries, I deal with the prep artists, I deal with a lot of these scientists, and it's amazing, they're all like this. You go to a show like Tucson, which is the largest show in the world, you have scientists from all over the world, you have commercial guys from all over the world, and what do? They share. All of them are so excited to see this. And the other guy's got that, and he's excited. So it's a really close-knit industry where everybody wants to get the facts and get them as right as they can get them. Okay?
Are there any members of the Geologists of Jackson Hole involved in this work?
I think we all are in our own way.
Right. And
And it's,
right.
yeah.
A number of people in the Geologists of Jackson Hole go to the Tucson show, I know, for example. But that's not necessarily scientific work.
But for example, I was at the quarry in Green River right before it closed last week of September and found a bird feather. And they find 2 a year. That's it. So just me being there and uncovering that was important. And somebody at some point will study that in a certain way and find out new and different things that we don't already know. And sometimes they correct information that isn't correct as the technology gets better to figure it out.
You mentioned that ammonites were useful in submarine research. Exactly.
Correct.
Exactly how?
Yeah, it helped them discover ballast systems, the buoyancy of how to make a submarine function in the water. So the chambers of those ammonites were so important in figuring that out because that's how that animal moved around the ocean.
Because then we could go up or down in the water column.
Oops. Go ahead. Go ahead,
Fran and Beverly.
My question is in the preparation, because you have alluded to 2 years, 18 years, and not in super scientific terms, but can you elaborate a little bit more than you did on how you get these sort of extraordinary revelations?
Well, a lot of them are accidental. So, for example, in Holzmaden, a lot of this shale, which is so close to being slate that they put years on it, I really can't, but it's a really close relationship. A lot of these were quarried for pool table tops. And when they're digging and breaking these things, they stumbled upon them. So it's how a lot of these are found. Solnhofen, on the other hand, is a totally different animal. You go, you take a 3-foot long chisel, you hammer it in the limestone, you split it. And you split it, and you split it until you find something. Once you know that it's there, these guys take forever to prepare. Why? Because it's so hard. These guys are a lot easier because they use little sandblasters with dolomite powder. Dolomite's harder than the limestone, so it removes it. It's softer than the actual fossil, so it doesn't damage the fossil. So to prepare pieces over here, it takes that much time, whereas these guys are this much time, just because of the material. In, say, the Green River Formation and also in the Solnhofen, what we're looking for in the limestone is bumps and dips. If the limestone has a dip in it, it's generally a plant fossil. It compresses it down. With an animal, the sediment that goes on it keeps piling up and piles up and makes a bump. Let me just take a quick peek here. This piece here, right here is a little dot. Do you see that? That's actually a fossil under there. And what that is it's coprolite. It's poo, probably fish poo. So for a little piece of poo, it makes a bump. Imagine the bump that would have been on that entire fossil. It would have had quite a big protrusion on there. And we look for that. And when we see that, we start to remove that limestone. A lot of times we'll get lucky, like on the dragonflies, and when you split it, because the fossil's harder than the limestone, it naturally wants to split where there's a fossil. And sometimes you get both halves, you get the positive and the negative. So those are a lot easier. But even if you see a bump, they'll stop what they're doing and they'll start to uncover that to see if there's anything under it. Does that help you?
Is it
Yeah,
sort of like,
how do they prepare the harbors? I mean, seriously.
It's just different materials, and it takes a long time. On the ichthyosaur, if you see, it almost looks like they've just chiseled it away. They have. Because it's so hard, you can't take a normal sandblaster. With dolomite, wouldn't even touch this. So they have to use different abrasives to help remove it. And the problem is, because this is so hard, then you take the risk of damaging the fossil. So, a piece like this, easily 2 years. Easily. Crinoids, like the big one that was in my gallery, 3-4 years to prepare that. When you look at it up close, and you'll get to see this one, you'll see all the individual pieces, and each one has to be individually cleaned, and it just takes forever.
so somebody's sitting there doing this?
That's all they do.
That's all they do.
That's all they do.
So when you say years, you mean like 40 hours a week, 50 weeks?
Some of these guys will work 10-hour days, some of them will work 8-hour days. It's just kind of an average, but yes. So imagine what you make a year, times 4 years, and you sell, this fossil is not that expensive, but the big one's 100,000. It's actually well priced because you're paying for somebody's time and expertise to do that. And then you have the rarity of the fossil to begin with. Yes?
When the crinoids are floating with their little piece of driftwood and they fall to the bottom, are they dying at the bottom, or do they kind of flip over and their little crinoids
No, they
wave
don't.
around on top?
The bottom environment in the Holzmaden is anoxic. There's no oxygen.
They go down there.
And crinoids are echinoderms. They're animals. They have respiration and they need oxygen. So
And they also need food. They're filter feeders, so there's
Right.
not much to feed off of
Right.
when there's no
And
life.
these were deep basins. These were 500-foot deep basins. They were floating on the top, and they had about a 2-foot stem so that they could reach a plankton-rich layer under the surface. But when you're at the bottom, there isn't anything to eat, there isn't any light, and there isn't any oxygen. So they die very quickly. Once the log sinks, they're gone. And the other interesting thing is, we don't even know how long these logs floated. 2 years. But then after Mount St. Helens, they said, well, some of these logs have been floating for 10. So this science is not settled. It's still happening. And we're still learning from events here and transferring to other places.
And crinoids are still alive today. There's still several species that are still alive
Yeah.
that have been studied.
Yeah, one group made it through the PT extinction event. And the Cretaceous extinction event barely touched them.
Where are they? These crinoids?
They live on coral reefs, and most of them, they're the ones with stalks, the sessile, the ones that are located with an anchorage or hold fast at the bottom, can be in very deep waters. Bahamas, Florida Keys, the individual ones live on coral reefs, and they actually can move, and so they can crawl around, get up to the top of the coral head, and feed at night, and then during the day they can find a little crevice to hide in, because these things are held together by muscle and ligaments, and so there are fish that will eat them, and they can find crinoid, especially in Solnhofen, they find crinoid pieces in animal guts and in coprolite. I think we have time for a couple more, and then we want people
Yes,
to
sir.
be able to.
I'm curious as to if Archaeopteryx
when you say it had teeth, are those like serrations in the bill, or is it actually a tooth in a socket?
It's actual tooth.
Tooth.
Okay.
That was the reptilian part of it was a mix of reptilian characteristics, bird characteristics.
And Archaeopteryx was the first to exhibit that, or pterosaurs had?
It had both characteristics of reptile and bird.
Right, the pterosaurs.
They call it the missing link
Right, or-
between dinosaurs and birds.
Or transitional is the term I prefer. The pterosaurs didn't have feathers. They had a type of fur, not like our fur, but a type of fur. The Archaeopteryx had true feathers, and the feathers they had are very similar to what bird feathers look like today.
Doug, take you to the dark side. I've heard that there's a quote, you talked a little bit about the museums and things are cast and not real. And I've also heard that there's a lot of, you can stumble into fakes that people are trying to sell. Could you tell us a little bit about that? What are actual people doing? And if you're in one of those other places that you might see something, what should you look for to make sure you don't?
It sounds like that should be one of the talks next year. That'd be a great talk, actually.
Yeah,
Because it encompasses a huge amount. Anything that has value, people fake. Everything. In the fossil world, fakes go very simply in Morocco, trilobites, which are the most common. They'll actually take a real rock, they'll carve it out, and they'll injection mold a trilobite into the real rock. So when you pick it up, it feels like it's got the right weight, it looks right, but it's a fake. Then you come down to things like pterosaurs. They'll take bones and carve them into skeletons. China, they'll do just about anything. And then you have dinosaurs, which when you go to most museums that have the real thing, you'll see numbers on some of the bones. Have you noticed that? The numbers on the bones, those are the real bones. And they catalog each bone and give it a serial number. So the bones that aren't numbered are actually made, they're castings to fill the bones. Is it a fake? Who knows? It is because it's not real, but yet it has real bones in it. So I think we should do a talk on it. Yeah. And can show you some amazing examples. All I can tell you if it's too good of a deal,
Exactly.
I'm telling you, I had a client come in and I had a trilobite that was $1,200. And it was a really fine Dicronurus out of Morocco. The lady went down the street and bought one and came back to me. She goes, I hate to break it to you, but the guy down the road's killing you. He had one for $99. And I said, really? So she showed it to me. I got on the internet and showed a slide of known fakes, and her exact trilobite in the exact same depth pose with the exact same breaks in the same area was photographed on them. And I looked at her and then, what are the chances that that animal died the same way, with the same break, in the same rock? So if it's too good of a deal, I promise you it's not. This stuff is so rare that pricing is I hate to say it, but I can put whatever price I want on them because you can't find these anywhere else. And to be able to compare things side by side is really difficult. So you have to be careful. If you have questions, you can always ask myself, Joseph, Kelly, who's not here right now. We'll always give you an honest opinion.
Mike, would you be able to, in any of these fossils, see their internal organs? And what I'm getting at is, the birds were the first of the four-chambered heart versus the first warm-blooded animals versus the reptiles. I think some of them were kind of an in-between, and I think caimans have some sort of a start of a fourth chamber heart. Can you differentiate that?
No, not to this date. Ice Age material, they've found mammoths that still have the brain, that have all the organs, have some of the food still in the stomach. But that's Ice Age, so we're way, way off. In Houston, there's a mummified Triceratops, which still has some of the original skin, which is pretty darn cool. But that's about as close as you're going to get to what you're asking.
What was the KT event?
I'm sorry, the KT event is geologic shorthand for Cretaceous Tertiary extinction event. 65 million years ago, an asteroid landed off the Yucatan coast. And
Landed?
It was a gentle landing. Took out all life forms, it's okay.
Landed, and it actually landed in a way that projected the blast zone northward into North America and pretty much wiped the slate clean here. Also killed off the dinosaurs. And it's marked by an iridium layer, which is a metal found in meteorites, but not generally found. And that's how it was actually discovered by a physicist who was studying rocks and said, why is all this iridium here? And iridiums come from meteorites, and it's a worldwide deposition of iridium. And that's how the facts kind of got put together.
Let's do one more, and then we're gonna have to wrap up. But I do want you to be able to get a close look at the fossils. Yes.
You mentioned with the fossilization process that there's carbonization and mineralization, and that there's actual tissue. How does that differ from petrified wood? And also the wood that some of these creatures are on, does that petrify? Is that different than fossilizing?
Petrification and fossilization is the same exact thing. Petrified trees, for instance, for example, in Arizona, there was a very large volcano 230 million years ago, covered the entire forest. Since the ash covered up all the organic material, the oxygen was blocked out. When there's oxygen present, it will not fossilize or petrify. It'll decay. Dead animal on the side of the road, good example. Leave it there for a month, go look at it. Leave it there for a year, go look at it. It slowly starts to decompose and break down. Same animal, bury it, take all the oxygen away, wait a couple million years and go back and look at it, it'll be a fossil. Okay?
Maybe.
Maybe. But with the oxygen present, it's not going to fossilize. It just will not. So petrification, fossilization, same thing. Just tree versus animal.
Okay, they're going to allow you to look at some of this stuff, but